Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So, testing mic. Testing. Testing, 1, 2, 3. Can you?
Ya, Doktor.
Yes,
Alright,
Doctor.
okay,
Ya, Doktor. Dengar.
alright. Okay, Assalamualaikum, very good morning to all. So,
Oh,
sekejap ada gema ke? Okay, let me just share my screen. Okay, can I know who this is, who just entered my class for this week, Can just reply in the chat there. Just enter in week 2. Share. Siapa nama? Okay. Please reply in the chat who just entered in week 2, Or is this all already entered my class last week, since last week? Okay. If last week, then I'm sure you all know the routine for this class. Okay, so just a quick routine check. So normally I will update all of the instruction in the ULearn. And also now we are at week 2, so basically all of the information are in here, so you can actually see. Example is for reference book. The main textbook that we are referring is to the main textbook here, Bolton. But of course, we have that different types of textbook that I refer to. Mostly, I will refer to almost 10 books, but the main one will be the from Bolton. So for the other reference book, you can look at in the teaching plan. There's a list of reference over there. And for week 1 is that we already completed chapter 1. Okay, so I did check that I'm not sure if everybody did join the group. So anyway, we just do a recap on the join the group according to the section. So right now, if it's correct, then we have mostly, so we have section 1, section 2, group 1, we have 23 students. And then for section 2, group 2, we have 20. So we have roughly about 43. So should be the attendance for today is 43. So let me just see the attendance, about 40. Okay, that might be correct. Okay, and then we have and normally during the class synchronized, okay, as mentioned in the feedback during week 1 is that we have classes either 2 ways, different types of method, which is the synchronous class. Synchronous class is like this, basically it's similar to face-to-face teaching, just that we are online like this. And then we have another type of category of class, which is a synchronous class. Synchronous class is basically all of the instruction will be given in the ULearn. Basically, of course, synchronous class also I will give instruction in ULearn, but it will not be complete. So the instruction will be delivered during the synchronous class. But for asynchronous class is that all of the instruction will be step by step, means that very instructional. So if student read through, they should be able to complete the asynchronous class. Okay, and normally for the asynchronous class will be the 1 hour class, and the 2 hours class will be for the synchronized. All right, so and we are going to have an activity using Padlet. As you all know, we have activity Padlet. The same Padlet will be used from week 1 to week 14. And also we are going to use Wakelet. Wakelet is where that I will actually share some important links from YouTube or even from notes. Also, I will actually connect it to the Wakelet. Okay, so there may be some different types of link to Wakelet that I will share later, depending on the lesson that we are going to go through. All right. So basically, what you have done was to in chapter 1, what you did was you go through the slides, then and I did actually explain a little bit on chapter 1, and then towards the end is that you did the feedback form. Okay, and in week 2 was that yesterday is you did a quiz covering chapter 1, means that on the terminology, on the introduction to the mechatronics, the basic idea behind the mechatronic system. So let me just go through the quiz yesterday. And in Telegram, actually, I posted that the student can have unlimited attempt. Okay, means that you can actually try out many times. There's no limitation. For the case of quiz is that because it's formative assessment. Formative assessment means that marks. The assessment is given to student as there will be no marks, but this is where you actually reflect back, either you understood about the topic or not. So maybe on the first trial is that you achieve maybe half marks, out of total 10 marks you get 5/10. So meaning that you need to actually improve the marks, of course, and you need to go through again I would suggest go through again the video chapter 1, and then go through the notes, the PowerPoint notes, and then try to do the quiz. Of course, the quiz is not simply just answer it, MCQ type question, multiple choice question. What you need to do is that for this one, for the quiz, if you click on the quiz, is that there is some instruction over there. Okay, so test your ability to explain basic concept of mechatronic system by attempting the quiz. So it's basically if you read through, okay, I hope that students don't just simply attempt the quiz without actually reading through the instruction. Okay, that is not a good way how to answer any assessment. So read through the title, okay, the question there. Okay, so you need to investigate definition and characteristic, okay, of the following terminology. So basically, ICS, Logi, ISM, using the N word of mechatronics, technology and mechanism. So you can actually find different types of wording that end with these 3 terms. And then just put it in the Google dictionary, just put it in the Google and find out what does it mean by science. What does it mean by mathematics? What does it mean by mechanical? What does it mean by electronics? So if you did go through all of this, you should be able to answer the quiz. Okay, if student did not go through this, okay, didn't plug in all the keywords into the Google, then basically you didn't get a full mark. Okay, so this is what you should do. Basically, this is where open book style is important for student to understand how to actually study for open book. It's not simply like the closed type assessment. Means you have the quiz, just do the quiz, basically. Okay, so it's not that. You should be able to refer to notes, refer to the internets. Of course, the answer will not be direct if it's in class. If it's in the midterm quiz, midterm exam, or in the final exam, it's not direct question. It's hot, higher order level thinking skill. So I'm not sure for the diploma student. Have you heard about HOTS? Not HOTS, panas higher order thinking skill. HOTS. Anyone heard about HOTS?
Higher order thinking skill, isn't it?
Yeah. Anyone heard about it?
Yeah.
Did you actually went through it during the diploma previously?
But
No.
bukan
But tu apa?
Kebat.
Okay, but. Okay, betul, kebat. Betul, kalau bahasa mudahnya lah kan. hebat Okay, kemahiran berfikir aras tinggi lah macam pelajar UPSR dulu kan. Dia ada kebat-kebat ni kan. Basically, the answer should not be direct. You should need to process the question, need to come up with the solution to answer it. Okay, so meaning that applying the fundamental to answer the question. Okay, so okay, let's just look at attempted quiz is by 46 student. Okay, apa tadi ada nampak macam ada komen mic dia. Mic. Okay, it's okay. Kalau tak ada mic, tak ada masalah. You can just write there in the chat Okay, not necessarily need to unmute Okay, so this one is you can just go through lah. I think you can see your marks, right? Can I just confirm you can see your marks directly after?
Yes, betul.
Yes kan? Okay, after
Not
I
directly,
think this
but
one is
it takes
just not directly.
No, but it takes some time to show people.
Oh, really? Okay. Maybe until 12 until the quiz is closed. Good. So basically, after you answer it, okay, just look at it. It's okay. Don't worry about the marks if it's low or not. Okay. So basically, this is the marks, and I can actually see the student answering the question, and then which question they answer wrongly. Okay. So basically, what I want to show is that this. Ada satu dapat satu. Who actually get 0.5 over 10 I'm not sure who is that. Okay, but anyway, overall from 46 students, you can see that the marks is skewed to the right side. Okay, skewed to the right side. So meaning that I think one student got 9.5 to 10 marks lah, means that one student only, almost full. The rest macam 9 to 2 student, 8, 5 student and so on lah. So the highest number of student actually get is 10 participant, student 7 marks. So more than half lah. So the rest of the student here, okay, so I will open again. I'm not sure. I think I opened the attempt until, let me just check the attempt. Is it closed already? Oh, it's already closed yesterday. Okay. Anyway, I will open it again for 1 week. So you guys just go try again the quiz. Don't worry, because it will take the highest mark. Okay. So if you get the highest, you already get full mark, then don't worry lah. Just leave it at that question, that marks. Okay. So for today is that. Okay. So we are going to do this topic, which is basically yesterday is that you did assessment, and then what we are going to learn today is about explain about sensor and transducer. Okay, student able to learn about and explain about sensor and transducer, performance, terminology, static and dynamic characteristic, and then explain the principle of several type of sensor and its application. Okay, so next, okay, this is what I call about a very instructional content course. So the next step is that, okay, because I think yesterday some of the student messaged me privately, mentioned that, sorry doctor, I forgot to take my attendance. So if possible, don't go and directly go and answer the quiz. You answer the quiz with by skipping this attendance. Okay, so make sure that attendance will be the first thing that you do at the beginning of the class, 9. And now it's 9, so do the attendance. It will be closed at 11 automatically. And I won't open it, okay, after that, because it's automatic. It's already for 14 weeks. I set it for 14 weeks. So I'm not going to change the attendance setting. So make sure that you did attendance already. Okay. And how to do that is just read the instruction, click on the submit attendance there and tick present. Okay, janganlah tick late ke, absent ke. You are here, don't tick absent pula. Don't tick late. Alright. So, and for class today is that we are going to have the synchronized class, and I already upload the chapter 2 notes and a bit of a sensor datasheet. I already upload, I think about roughly 6 datasheet inside there that will be linked to our exercise later on. And we have the instruction here. Okay, should be by now you already download the notes for PowerPoint chapter 2. Okay, I mentioned here is that print the slides to prepare your own notes, go. So basically, how I PDF the slide is that you have ample space to write on the right side there. Okay, so take that opportunity to actually write down your own notes. So this is how you train yourself to do notes for your class. And then we have basically for this chapter we have 3 exercises later on. Okay, this one will be guided. I will guide you. Alright. And two of the exercise is going to be submitted through Padlet. Exercise 1 and 2 is through Padlet, which is already up inside Padlet. And also for exercise 3 is that it's going to be submitted to Yulen here. Exercise 2, exercise 2 to Yulen, exercise 3 to Padlet. Okay, that's wrong. Exercise. Okay, let me just edit that. Yulen, to Yulen. You guys are diploma luar, so I'm just scared that you will think that it's correct. Okay, so basically that is what we are going to do today. And then towards the end, we have the reflection for the class. So we have a reflection, and basically it will be open after class. After 11, it will open. So there will be some question which is referring to the exercise. So you need to answer the feedback after you have done all the exercise. Okay, and it's open until this Friday. Okay, so not going to be submitted today. Okay, but before that, I just want to mention there are a feedback form that I gave to student last week. Okay, last week I gave feedback to student, and there was some student who, because in my questions that one of the response was on the what's the question? Okay. I think the question was based on today class, which part of the notes you didn't understood. So I went through all the comment by student. Okay. Most of the student mentioned that I would like to learn more about the die bond process, basically on the front end and back end. Okay, that one I will go through. Okay. Before we start chapter 2. And then, okay, back end not clear, cannot understand back end. Okay, die process, okay, basically based mostly on the processes of the front end and back end. Okay, let me just go through. Okay, tak faham back end, alright. Don't quite understand process of ball screw. Okay, ball screw later on I'm going to explain. But anyway, don't worry. Ball screw is actually a part of the mechanical actuator, which is you are going to learn in chapter 6. Chapter 6. So if you don't understand right now, don't worry. We are going to go to chapter 6 later on to learn more on the ball screw. Okay. Front end, basically that one. And I noticed that one student, which is good. One student explained that. This one. Can share the link video in slide to automatically click as I cannot see the process through it. Yeah, I just noticed that. Sorry about that. Okay, so I already upload the notes where you can actually click on the PowerPoint and link directly. So you can download that notes again. Okay, this one is the updated notes. So in this note is that, okay, I already link ensure that the link in the notes can be clicked. So it means that like this. Okay, continuous control system. So you just click there, and it will directly send you to the this page. Okay, so this is diagram process. Alright, so I'm going to skip that. Okay, so just download the notes, the latest note that I upload to chapter 1. Okay, so I will just go through very quickly. Okay, what I'm going to go to do today is that, okay, on the recap on chapter 1. Okay, on chapter 1 was that basically what you have learned is that you're able to explain the concept of mechatronics system, which is mapping to the learning outcome 1. So And in these slides, I share to student the definition, explain it, the definition, and it's in the recorded video. The history of mechatronics, job scope. I'm not sure if I went through the video, but I think it's not there. But anyway, I will explain just very fast. An example of application. Okay, so okay, I will just make a summary. Okay, so after chapter 1, going through all the chapter 1, you have found out that there are 3 main key elements or control block for mechatronic system. The first one is the measurement system. Okay, measurement system. The second one is the control system. And the third one is the actuator system. Okay, so which one is which? So the one in the red part here, okay, is actually the actuator system, whereby you see that the actuator system comprises of the actuators. Okay, it doesn't mean that all the actuators are in the system. It might be one actuator are being used. And also, as mentioned in the video, okay, recorded video, is that most of the time when we have actuator, we need to have a signal conditioning. Okay, so that's why you have also the signal conditioning inside the actuator system to actually convert from digital to analog and analog to digital. Or you need to amplify the signal from the controller, or you need to actually add some path width modulation inside here. Okay, that will be the first system. And the second system will be the measurement system. So where is the measurement system? Measurement system is underneath here, which is we have the sensor. Okay, sensor. So it can be any sensor, displacement sensor, force sensor, speed sensor, and so on. So all of those are types of sensor. And sensor also, it will be embedded with the signal conditioning block. So measurement system normally have the signal, the sensor. You have the signal conditioning, which is signal conditioning is same with the actuator system. You have the amplification, you have the filtering. Of course, you have filtering of the sensor. Normally, you need to filter noises. Okay, so you need to have filtering. And towards the end here, normally after sensors, you have the data presentation. So all of those topics, we are going to learn it in the in chapter 1. Chapter 2. Chapter 2 will be sensor. Chapter 3 will be signal conditioning. Okay, and chapter 4 will be on the data presentation. Okay, chapter 5 will be covering on the pneumatic and hydraulic. Okay, and chapter 6 will be on the mechanism. Okay, you see that there is no mechanism inside here. Later on, I will explain why. Okay, because mechanism normally it will actually embedded with the hydraulic and electrical. Okay, so that will be the key element of mechatronic. Okay, so I think I've gone through that video. Okay, so one of the process that student mentioned about is die bond process. Okay, die bond process. So what are die bond process? And you can see here is that die bond process is part of the back end process. So to explain that, I'm going to directly jump to another slide, which is actually chapter 8, the last chapter for this subject, so that you get an idea why you are learning all of this, why Dr. Mariam is sharing these processes, semiconductor processes. Okay, so let me just open that slide. Okay, so this slide, I have not yet uploaded to Yulen because this is chapter 8. But since there are students asking the question, so I might as well explain it. So if you see here in chapter 8 is that basically students are going to able to explain the types of control system, the principle of the basics control system and application. Okay, and if you go through this one, normally I will repeat again the slides. Okay, so we have the actuator system, we have the measurement system, and the whole thing, the whole block over here will be the control system. Okay, and I'll just skip that. I'm going to go to the process. Okay, the front end and back end process. Okay, so student asks, just small. Okay. Okay, in semiconductor, can you see my screen? I'm writing semiconductor. We have the front end, and then we have the back end. Okay, so front end is where we have the wafer fabrication over here. And then for the back end is basically assembly or packaging. So wafer fabrication is that, what is wafer? So this is wafer. This is the end product at the front end. It's a wafer. So it's similar to what the wafer that you eat. Wafer, how do you see it? You have a wafer, something like this, a circle, and then you have some like square there, right? Wafer. So basically, on top of this wafer, there's a chip there, which is we don't call it a chip. Chip is something that at the end product of the back end, so we call it as the chip. But for the wafer is that on top of this, we call it as the die. Die, a small fabricated chip on top of the die. So what happened is that this wafer, okay, from the front end, okay, example, I take an example of Infineon. Infineon, we have two branch, which is we have the one in Kulim and the one in Melaka. Okay, so in Kulim is that we have the front end, and in Melaka is we have the back end. So basically, it's different product output over there. So in Kulim is that they actually come out with the wafer fabrication, and that wafer fabrication will be sent to Melaka to actually assembly it and become a chip. The chip that is being sent to the company, to other company, which is to the consumer. Example is consumer, like Honda, Proton. Okay, consumer, what type of chip are being sold to this consumer? Example are airbag chip. Okay, to the controller to control the airbag. So this is example of the chip being sold to the consumer from the Melaka back end. Okay, so for wafer fabrication process, if you see here, I'm going to open this slide. Okay, so there are many processes. Okay, the first one will be, I cannot write here. Okay, sorry, I cannot write here. So the first wafer fabrication will be the incoming wafer, first process, wafer coming in, and mostly that wafer coming in is from Germany, Infineon. Okay, so that wafer coming in, and then next process is epitaxy, diffusion. So all of these are processes, and each processes they have the machine over there. Okay, means that each processes have the engineer, have the technician, have the operator over there. Okay, so we have all of those processes until the probe and trim. And finally, will be sent out to the Melaka. Okay, and what I want to share is that the die bond processes, okay, in the back end. So back end processes, okay, if I were to show this slide, is on the, okay, we call the die bond processes is under the back end, okay, assembly, okay. So in Melaka is assembly processes. They do not come out with any wafer. They are actually assemble it to become a chip. Okay, so they have a chip pre-assembly. The wafer coming in, we have one chip. Okay, sorry, one wafer. So lots of wafer. Basically, they will send lots of wafer to this to the Melaka site, and then next process will be the laminator. Laminate first the top part, and next process will be back grind, mounting, and detaping. So back grind is that basically the wafer that being sent from Kulim to Melaka is a bit thick, and they're going to back grind the bottom part. Back grind it to be very thin, okay, before they go to the sawing process. So sawing process is basically to it. We have the wafer. Okay, you know that the wafer have this lots of die on top of this wafer. Okay, example, this is the die. So they are going to cut the wafer at this line, cut it. Okay, so that we call it as sawing processes. Okay, next after pre-assembly, we have the front of line. This is where I mentioned we have front of line and end of line, or end of line over here. So assembly process for front of line and end of line have different environment. whereby the environment of dust. So they need to use different suit to enter the assembly line, front of line, or the end of line. Okay, different processes. So normally for the front of line, the engineers or the technician operator, they need to wear the full suit, the white suit. Basically from top to bottom, it's like if you have seen it, it's like in the video that I shared to you. So they were wearing a overall, full overall, even their head, and then wearing the glasses. Okay, so the first part of the front of line process will be the die bond. Okay, so what is die bond? Die bond process is basically after sewing. So after sewing, the chip will be cut into one piece like this separately, right? Okay, so you're going to actually bond it to the frame. Okay, there's a frame, so you're going to bond it to the frame. So later on, I think you can try to go through the video. Okay, this one is the video. Okay, so this is back grinding. Okay, laminating, wafer sawing. Okay, and then die bond means that they're going to pick the die, which is cut from that wafer, and then put it on the frame. Okay, die bond, and it's going to be cured using a glue. Okay, so these are the processes. Okay, and next after cured is next will be the wire bond processes. Okay, wire bond processes is basically like soldering, but using a very small distance a solder. Okay, it's very small in nanometer, so they're going to solder using machine automation. Okay, and next is QC gate to check the quality at the end of the front of line. Of course, for each of the processes, also they have the quality check for each batch. And after that, all of this product is going to be sent to the end of line. And at the end of line is a bit robust. So they are going to go to the mold. This is where you see the chip that have the black mold, the plastic mold there. So this is basically mold and encapsulated on top of the chip there. Okay, and then post mold curing, dedamp and dejunk is basically to remove all the extra mold there on top of the processes. And next is marking. Marking is means that the chip sometimes if you know that it's come from Infineon, it's come from ST, you come it from the Texas Instrument. So there's the chop there. So that is what we call it as the laser marking, chop on top of the chip. And next is X-ray. X-ray is basically a form of QC check also. So they are going to do an X-ray top view, X-ray directly, and look at the connection wiring. So they can directly see if there is any wire overlapping or not connected to the point. So that is one thing. And they will also have the QC check using some instrumentation. So to check directly if the chip is good to be sent out. Okay. And lastly is the packaging and shipment. So that is basically the process at the front of line. Okay, and back end of line. So okay, some student mentioned about the process of ball screw. Ball screw. But I think I will just skip that first. Okay, because later on in chapter 6 we are going to go through. But anyway, you can just search in YouTube ball screw mechanism. So lots of video explaining about the ball screw mechanism. And I would suggest to student, other than, it's good that you mentioned that you don't understand this and that and so on. I would suggest, other than asking, if you still do not understand after looking through some YouTube or Google it, then you can ask the question. But if you still cannot understand, then it's okay. I will try to explain. Okay, so next. Ya, kejap. Tengah nak tengok slide. Sorry. Kejap. Mana chapter 1? Okay, chapter 1. Okay, okay, in the slides, I think in the slide, it basically my notes stop at 29, and then the recording stops. So, but basically you can just go through for each explanation. You can go through this Diabolo Processor. Okay. Well, if I were to click that. Okay, so this is diaphragm processors. You see that there's a robot picking up all the die. This die is already being type saw processors, so it's going to be picking up die and put it on the frame. So you see that this is on the frame here. So this is the process of diaphragm process. Okay, and after that, of course, on top of this frame, they already put the glue, the glue on top of the frame. So they're going to pick it automatically. This is use automation. You have to put the diaphragm processors. Okay, so that is what plan to explain, recap on chapter 1. And you can also go through this Mechatronics job scope. Okay, I think you can just click on here, call for video job. Okay, and I just want to share, okay, example of Infineon job search. So you see it there. I'm not sure if it's working. This one was a long time ago, but anyway, let's just look at it. If see accept. Okay, you can just see here. Okay, example. You just type there process engineer. Okay. You can see that, and then you can pick, because if you didn't have lots of branches, so you want to pick Malaysia. Okay, so you can see there is a few opening. Okay, senior engineer processes wafer thinning. Okay, this is in Kulim. Senior wafer maintenance. Okay, maintenance process is different type of engineer. Okay, so processes is only on the processes. Maintenance is maintaining of the equipment. So senior engineer product engineering. So basically to design the product. Okay, this is basically on the R&D. Because you see that there's a Kulim there. So Kulim, they have the R&D over there. Okay, Malacca side, we don't have the R&D. They mostly on the assembly. So this is where you can just go through my slide later on to look at the link. Yes. So okay. Okay, and then towards the end here is that I have example of Mechatronics system. Okay, so just go through example, nothing much, just go through the. If you don't understand what does it mean, then try to pick up the key point. Example, micro factory drilling unit. Put it in YouTube, and you will find that explanation. CNC bending, what does it mean? Okay, CNC machine, what does it mean? Okay, and then you can look at all of the example. Okay, Mechatronics system. So why I share all of this, because all of the system basically they have all of the 3 block diagram. They have the sensor, okay, sensor, the measurement system. Basically, they have the actuator system, and also they have the control system. So try to identify from this class, from this application, what type of sensor that is being used, what type of actuator being used, and what type of controller that you think it being used. Okay, so basically, if from the previous semester is after finishing everything, student need to actually come up with the group discussion, but this one no need. Okay, just look at the task, and if you have time, do it on your own. Okay, so that will be all on the recap for chapter 1. So we are going to go to chapter 2. Any question before I go to chapter 2? Any question? No? Okay, if no question, then we are going to go directly chapter 2. So basically, chapter 2 will be mapped to the LO1 and LO2. So by the end of this chapter, which is sensor and transducer, okay, you are able to explain the concept of mechatronics and the working principle of the sensor and transducer. Okay, so what you are going to learn is about explaining the system performance terminology. Okay, category different type of sensor is measured quantities and sensor operating principle. And select the suitable sensor for different type of measurement and able to explain its application. So we are going to use the same case study from chapter 1, the same case study, and you are going to determine what type of sensor that was being used. So of course, for the breakout session, you are going to be randomly picked. So why randomly picked, not with the same group? Because you get to know each other and get to communicate with each other. Okay, and I did actually read through the comment. I think this one I need to highlight also. Okay, by some student mentioned, I don't want to show that. Some student mentioned that the breakout session was actually good, okay, but there were some cons that student actually shared. One thing is that in the group, as a group, some students are not cooperating. No discussion, silent mode. Okay, so that shouldn't be the idea. Okay, if I were the group member, okay, if I were in the group member, the team leader means that the team leader who lead that team. If there are group member that is silent, then in the submission padlet, just don't put their names. Okay, memang kejam lah. For me, kejam. But if they don't want to commit, then don't put their names. Okay. Similar goes to the assignment, the group assessment, the group task for exercise 2 that you will need to submit to ULearn. If in the group there is no discussion with that student, so you don't need to take his name. Okay, basically, if they do not give you the names, the metric number, then don't put their names lah, tu saja. Don't need to worry about them. So, if you all are here to study, to be a mechatronic engineer later on, so you need to start communicating with your peers, with your friends. Cannot be silent. Okay, if you have problem with your mic, use the chat to communicate. Okay, use the chat to communicate. Don't be silent. So this is just a reminder to those students who are not talking in the group breakout session. If you don't want, we are in the pandemic right now. Okay, endemic basically, and hopefully, towards later on when we have the face-to-face class, we have a group discussion also. So students need to communicate. So because reason why, when you work, you need to also communicate. You cannot be silent there without doing anything. Okay, end up you're going to be sacked out. Sacked out ni kena buang kerja lah. Okay, not communicating well with the others. So that is one thing that I'm going to share. Okay, the key point about the breakout session. Okay, but overall, most of the students say that it's good due to the fact that students can actually learn to get to know each other. So right now for your sensor and transducer is that we are going to concentrate on this part. This part, which is on the measurement system block. So we are going to focus only on the sensor part. Okay, this is example, vision, encoder, and force. Of course, we are going to go through other type of sensor. So what are sensor? Sensor is basically are defined as a device which is used to measure physical quality. Physical quality. Just look. Oh yeah. Okay, physical quality. For example, light, sound, temperature, okay, or force. You want to measure force, so you want to actually measure that. So it's basically measuring something. Example. Okay. Kejap mana pergi? So example is that nowadays during the pandemic, what of sensor that you usually use? What do you think that you normally every day you use it? Can you share in the chat?
Thermosensor.
Yes, correct. So thermometer is actually sensor kan. You go to the shop, you need to check.
Yeah, can.
So that is one type of sensor. Okay, but does it actually display anything? Yeah, it display the value, right? So you have a display unit also. So basically, the thermometer have two types of component inside it. They have the sensor to detect the measurement, and also they have the display unit, the LCD, basically. Okay, the 7 segment to display what is the reading, 36.7, 35.8, and so on. So those are type of sensor. But when we talk about mechatronic system, it's a sensor that actually can give feedback to us. Okay, so means that the output can be collected and can be feedback to the reference to actually compare and get the error with the reference. Okay, so those are example of sensor. Okay, so patutlah you boleh jawab thermometer sebab dah ada so saya tak perasan. So that one is one example. Okay, but what is transducer? So transducer is actually similar to sensor. Okay, it can measure similar qualities to a sensor, but will convert the signal from one physical form to another, meaning their input and output signal are not the same. Okay, transducer are sometimes referred to energy converter. Okay, so a transducer will convert measurement into an electrical signal. So example is, okay, let's say that we take an example of input transducer takes the form of energy converted into electrical signal, and for output transducer is that it takes the electric and convert it to another form of energy. So example is that sensor is a light bulb. Okay, light bulb that detects motion. Okay, so basically you need to have a motion sensor. Okay, that motion sensor is connected to the light bulb. So detecting that, then it will actually lighten up another form of product output. Okay, so we call that as a converting. Okay, converting from electricity to motion. So that motion sensor is called a transducer. Okay, and that motion sensor is also a sensor because it can detect movement. Just that it's going to convert from electrical to motion, and when detecting motion, it's basically it's detecting the displacement. Okay, because motion is detecting the displacement, the jarak lah antara objek dengan sensor, right? So what are types of measurement system that we have? Basically, we have the motion. The common one is the motion type. Okay, force. Okay, temperature, pressure, flow. And you see that here is that when we talk about motion is that it doesn't mention displacement. So basically, when we talk about motion, it's detecting the displacement, jarak. So, and all of these are called sensor. Okay, these are physical quantities. So motion, force, temperature are physical quantities, and it can be detected using a sensor. And this sensor will normally need to have a signal conditioning. Means that it need to convert from electrical signal or from motion to a signal in terms of voltage or current. So this is where you need the signal conditioning. And lastly is that it's going to display it. For example, that thermometer just now is going to just display the reading, or if you have a controller, then it's going to feedback it to a system. So the basic, I would say the basic concept of the system, we take one example is Tesla. Okay, anyone know about Tesla, the car, electric car? Anyone know about Tesla?
Yes. Yes, doctor.
Mestilah kan. And anyone know about X70? X70, not the S70.
Yeah.
I just noticed that X70 ada phone juga Vivo phone X70. Okay, I saw it in the bulletin TV3, selalu TV3 dia ada Vivo X70. I was thinking kenapa lah dia iklan X70 rupanya there's a handphone, dia punya model dia X70. Okay, X70 sama dengan kereta so okay, maybe Proton tak buat copyright lah tu kan, so X70 so basically you see here last time when I was teaching the advanced manufacturing system for your student, I actually bring student to visit Proton COE Center of Excellence at Shah Alam. And this was back in 2019 before the COVID happened. And what actually brought them to look at the processes at the Proton COE, the assembly processes. So we did look on the assembly processes. You see here you have the MVF, multi-vehicle factory at Proton. So I think there were roughly 2 buses. I bring student 2 bus, and actually, I was lucky to actually get the slot because one of the manager over there was my friend from my school last time at Sam Justin. So he was one of the manager over there. So he actually So he was one of the person who explained about the visit. And also, actually, if you see here, all the students looking at this person explaining about this engine, right? So this is engineer actually is my brother, my older brother. He's a manager at the research department on engine, okay, in production for engine, designing engine for Proton lah. One of the engine that they developed was for the X50 also. The current one X50 also engine by Proton. So he's one of the person in charge lah. Okay, so I didn't want to share that. I wanted to share about the video on this one. So one example of Mechatronics system that you can see in a car, okay, is on example is Tesla. Another one that is locally is X70 lah. If you have X70 at home, then you know all of this. So basically, if you see here is that Tesla is actually 100% electrical vehicle. Okay, and it's autopilot. And if you see here, I think the link, maybe the link is not there. Okay, but the link later on I will show to you. Okay, just look at this video. Okay, so if you see this video, it's inside Tesla. Okay, the person is not actually holding the steering at all, so it automated. And you see that on the left side here, right side here, is that you have the left vehicle camera. Okay, left, you have the medium range camera, and then you have the I think this is right vehicle camera. Okay, so they are using the camera to detect obstacle. Okay, you see the obstacle, the green, blue, and so on. So I think the blue is to detect the human code. And then they also detect the line. So basically, Tesla can actually do line following, because not line following. It's actually to detect, to ensure that the car is inside the lane. Okay, so this is all using, like your friend said, is using AI, and it's adaptive control. It adapt to environment. It does not only have AI, it actually adaptable to environment. Okay, so later, I think this one you can just look it, try to search. I give you the link. You can just save that link. Okay, or I can just share it in Bakelite later on. Okay, just close that. Okay, so one of the common thing is on the Tesla or even X70, they have that also. X70, mostly they have the currently they call it as the ACC, Adaptive Cruise Control. Last time when we have the Inspira, because I used Inspira. So Inspira, they have the cruise control. Cruise control, basically you can set the car to actually cruise at certain speed. So you want to set the speed at 120 km per hour, example, to avoid any summon kan. So you set the speed 120 km per hour at the highway, and the car is basically going to drive automatically, but the steering you need to still hold it, okay, to maintain the the distance. Okay, but in X70 is that they have the upgraded one, which is the adaptive cruise control. So when we talk about adaptive cruise control, is that it adapt to the distance with the front car. So previously, when we have the cruise control only, when our car is near to the front car, it's not going to stop. Okay, so it's just going to speed up and crash into that next car. That is what it means by cruise control. So you just control the speed, okay, without having any sensor to detect any obstacle in front of you or back at the back. Okay, but when we have in X70, they have the adaptive cruise control. So basically, they have all of the sensor. They have lots of sensor. I think basically they have the ultrasonic sensor. Overall, around the car, basically I think 8 sensors kot. Depan ada 3, tepi, belakang ada lots of sensor. So that sensor is going to detect the distance with the front car. Okay, so when it detect the car in front, the car X70 will directly start to slow down, braking. Okay, without the human braking. Okay, so this is what we call as adaptive cruise control. And after that, if the car in front already go to the right, okay, so the car directly automatically speed again to the reference that we set. So this is what we call as adaptive cruise control. A very simple idea on mechatronic system that has been applied to a real environment. Okay, so let's look at this example. So okay, so we look at this example. Okay, I think you have seen it when you are doing diploma for the student who did diploma already. So you have seen this block diagram, and mostly when you look at a block diagram, this main block will be called as the block diagram of the system. So I'm going to draw that. So basically, you have something like this. You have we call this the block diagram with the system, complete with the controller inside. Okay, and when you have you want to control a certain reference, then you need to have a feedback loop. So feedback loop means that basically you are going to calculate what is the error between the reference with the output. Okay, so you will see that most of the time, you don't see this type of block. You actually seen this block. So if you see here, actuator system is normally connected to a measurement system. Okay, let me just take an example of a DC motor. Okay, if you buy a DC motor at the shop, DC motor, a very small DC motor, okay, DC motor do not have any sensor. Okay, unless you buy a DC motor with encoder. So there is an encoder connected to the DC motor. If there is no sensor, means that the DC motor, when you give an input, you give a voltage, what happens that it's going to actually rotate with the same speed. Okay, you cannot control the speed unless you control the input voltage. Okay, you want to give it 5 volt or 10 volt. So the more higher the voltage, the more higher the speed. So that is how you control if it's a open loop. Okay, that is example of an open loop. Okay, but nowadays they sell a DC motor with encoder. You can type that DC motor with encoder directly. They have the encoder attached to the DC motor. So that is whereby we have, normally you will see that something like this. The actuator system is combined with the measurement system. They have the sensor together. So when you have this type of block, then the output is look like this. Okay, same thing. It's same thing. So if you remember signal flow graph in control block diagram last time, you can actually bring this block above here. So that's why it can end up looking like this. Okay. Okay. So in the measurement system later on, you are going to look at this part later. Okay, so chapter 2 will be on sensor and transducer. Signal conditioning will be chapter 3, and data presentation will be chapter 4. So basically, it will be covering 3 different chapters. Yeah, I'm going to skip that. This one I already explained just now. So about the signal condition element, okay, the data presentation, what it is, okay, display data, graph, indicator, okay. So I'm going to skip that. You can just go through. Just directly go to the sensor performance characteristic okay, on the types of characteristic, because it will be the exercise number 1. So for this sensor characteristic is that basically when you purchase a sensor, okay, before you purchase a sensor, you want to actually check what is the data sheet. What are the input? Is it voltage? Is it current that is required for that sensor? And then what are the output range? Is it the range of the, for example, if you plan to buy a displacement sensor, can it detect up to 50 centimeter, or does it can only detect up to 1 centimeter? So you need to check that data sheet, the performance. So I'm sure you have seen a data sheet before. And what you want to look at a data sheet is that on the static and dynamic characteristic. So on static and characteristic are the value given when the steady state condition occur, which is after sensor have settled down after receiving inputs. Okay, so basically this type of static characteristic are in the data sheet. Okay, you can directly look at, what are the span value, what are the range value, what are the accuracy, what are the input, what are the gain. Okay, all are in the data sheet. And dynamic characteristic is the behavior of the sensor in transient conditions. So basically, when you want to check the dynamic characteristic is that you need to actually test it. Okay, test it in real life. Okay, you give an input, you collect the output and plot in a graph, and to see the behavior in transient condition. So there are 11 types of static characteristic that can be referred to in a data sheet. Normally, you want to check if there is a range and span. You want to check what is the error reading. You want to check what is the accuracy, sensitivity, hysteresis, if there is any hysteresis value, non-linearity, okay, repeatility or reproducibility, okay, stability, deadband, resolution, and output impedance. So if you look at the first one, range and span, is basically, if you look here, okay, the range is of a transistor is limit between the input that it can vary. Okay, and the span is the maximum value that the input minus the minimum value. So basically minus maximum minus the minimum. Okay, so if we take an example for a load cell. So load cell is a type of force sensor. Okay, to measure a force that have a range of 0 to 50 kilometer. Therefore, the span is 50 kilonewton. Okay, so these are example. And if we take another example of thermocouple, okay, so we can say that the input range of the thermocouple is from 100 to 200 degrees Celsius. Okay, and the output range is 4 to 20 milliampere. Okay, output range means that the reading, normally from a sensor, the reading should be in either voltage or current. The reading, it means that the reading tapped directly from the sensor. The reading will not be the reading in Celsius. Okay, this is the gain lah. Basically, you can actually look here is the gain. Basically, if I were to write here, okay, this one, okay, they say the range is 4 to 20 milliampere. Okay, and it says here the range of the input is 100 to 200 degree. So basically, if you have 100 degrees Celsius, then it's going to give you a reading of 4 milliampere. If you have the value of 250 degree, then it's going to give you a 220 milliampere. So that's what it means by this one. Example of input range. And the span value is, what was it? Is the variation between the maximum minus the minimum. So you have the 250 minus 100. This one. So you get the variation is 150 degree, and the span of the range of in milliampere is 60 milliamp. So this is example. So later on, you will refer to the example D5. D5 is what? Okay, D5 is you need to look at the ULearn, the data sheet that I upload in ULearn. So basically, in ULearn, go to week 2. week 2. Okay, beside the notes chapter 2, there's a sensor datasheet there. Okay, and there I have uploaded 6 datasheet. Okay, datasheet number 1 is Dacel. Dacel is the force sensor. Honeywell torque sensor. Second one is torque sensor. Kiowa is Kiowa is what sensor? I'm not sure. Just check it. And then load sensor, load cell, and then we have the infrared sensor and Dacel. Okay, so different type of sensor. Okay. And you see here that the first sensor is Dacel TRB and Dacel TRC. This different model. Okay, different model means that different range and different span value. So later, what you're going to do in the breakout session is that you're going to go through the content, okay, of each of the datasheet according to group. Okay, that one is the first one, range and span. Second one is error. So the error is the difference between measured and the true value of quantity being measured. So basically, this one error when we have a block diagram lah, closed loop diagram. You have the closed loop. You have a block diagram here. If you have a block diagram like this is an open loop. And you know that when you want to make it into a closed loop, then you have a feedback form, plus and minus over here. So error is at this point. Error is minus here. So it's basically measured value. This is measured value minus the true value. So true value is over here. So error minus true value, you get the error value. Okay. So if you have something like this, actual value is 26 and measured value at this end is 25, then you have an error of minus 1 degree. Exercise. Draw the closed loop block diagram and label each parameter. I already draw it for you. Okay, sorry for that. But you can draw it on your own in the notes. Third one will be on the accuracy. Okay, so what is accuracy? So it's defined as the largest expected error between actual and ideal output signal. Okay. Sometimes this is quoted as a fraction of full-scale output. For example, the thermometer might be guaranteed accurate to 5% of full-scale output. Okay, so meaning that, okay, let's say we take a temperature sensor. It says that the accuracy is plus minus 2 degrees. So temperature sensor, if you buy a temperature sensor, it says there it can detect measurement up to, example, 100 degree. Okay. But in the datasheet, it mentioned that the accuracy is plus minus 2 degree. Means that it will give you either 102 degree or 98 degree, depending on that sensor that you purchase. Okay, because you know, when doing the manufacturing processes, assembly, there are some sensor, you cannot have the same value. Okay, unless it's simulation, then you can have exact value 100 degree. But when you assemble, you produce it, some of the accuracy, when they do the testing, the accuracy of the equipment or the sensor, it will go up to plus minus 2 degrees. So that is what it means lah. So it means that it can go up to 102 degree or 98 degree. So they mention it also in the datasheet. Okay. Okay. Alright. Next is the sensitivity. Okay, sensitivity here is defined as the term of the relationship between input physical system and output electrical system. Okay, so basically, I already explained the sensitivity just now, but maybe you didn't get that idea. Is this part? Okay, sensitivity means that you know that the current or voltage value will give you a value of the output in terms of temperature. Okay, so sensitive means that actually is the calculation of gain. Okay, you see here the ratio between a small changes in electrical signal, small changes in physical signal. Okay, so that's why you see here the typical unit for sensitivity might be in voltage over Kelvin or voltage over degree. Okay, or for example, if you have a displacement sensor, then you have a voltage over millimeter, okay, in displacement, or sometimes you have a voltage over centimeter. Okay, so sensitivity of the reading. And how to calculate that? It's very simple lah. Gain kan, dia sebenarnya gain. So you have the output minus the input, then you have the sensitivity value. So you get the gain value. Okay, try to do this. Okay, hysteresis next, we go to hysteresis. So hysteresis is that, it's mentioned here is that some sensors do not return the same value output when the input stream is cycled up and down. Okay, the width of the expected error in terms of measured quantity is defined as hysteresis. So mean that, okay, example, you have a temperature sensor just now. Is it temperature? For example, this one is resistant with the flow rate. Okay, we have a sensor over here. So they are going to give a rise, volatility rise here. So it's going to rise like this. Rise up until this value, flow rate at 25 milli per second. And then after that, they reduce it. So the voltage actually drop, but with a different route. Okay, when a different route between this rise and drop, then we call this as hysteresis. So this is the hysteresis between the rising and the drop value, decreasing value. So this sometimes the sensor have this type of hysteresis. Not all sensor. So this one normally they will also mention it in the datasheet. Okay, next will be on the non-linearity. Okay, non-linearity sensor, I don't think it's common. Normally, all of the sensor are linear sensor. So, what does it mean by non-linearity is that this one. You have a linear sensor reading, straight line, and you have a non-linearity sensor. So, it's going to give you the same reading at the end here. But you see here, there is a gap. There is a slight difference when you start to give a value. Okay, so increasing value that is not the same with this linear value. So this is what it means by non-linear. Sometimes it gives you a non-linear like this, okay, and something like this. It is not actually the same set point at the end. So there's a cross at this point. Okay, so this is something that you need to take note, because sometimes students just buy sensor without taking note on the data sheet. So they will just test it out and then they find out that, wait, why does my reading does not the same as what if I test the sensor on its own. But when you connect to a actuator, the reading is different. So you need to troubleshoot the sensor. I would suggest normally for my students when I do the final year project is that they purchase a sensor. They need to test the sensor on its own. Give an input to the sensor according to the datasheet. So if the datasheet says that the voltage the maximum voltage to the sensor is 10 volt. So they test it from 0 to 10 volt. So 0 and then capture the data. 1 volt capture the data. 2 volt capture data, and so on. So when they have all those plotting data, they are going to plot it into a graph. So later, okay, in a data sheet, you will find out that they will normally give you a graph like this. And then after testing, the student already testing it in real life. So they have the data and they're going to actually compare it with the data sheet. So if it's the same, then means that the sensor that it's purchased is good. Okay, sometimes there is a bit off, so you need to take note on that. Okay, next is on the repeatability. Okay, repeatability is ability to reproduce the output signal exactly when the same measured input is applied under the same environment. Okay, so it means that you're going to actually repeat again. Repeat and repeat means that repeat 1,000 times. Is it going to give you the same value? Okay, so this is what it means by repeatability. Normally, when you are doing an experiment in a final year project, most of the time we will ask students to check repeatability at least 3 times, at least. But for my case is that normally I ask for FIP student is 5 times. For master student, 20 times repeatability of the same experiment to check that it's actually repeatable. Okay, lastly is the second last will be the stability. Okay, able to give the same output when measured a constant period of time. So stability and repeatability is almost the same, but stability is when you give an input to the system, okay, and then you just run it for 8 hours. So is the data stable? Is it going to give you the increment data or going down? Okay, so when you do this type of stability testing, you need to have another sensor to as a reference. So that's where you can actually manage to compare the data. Next one will be deadband. Okay, deadband is where the sensor doesn't detect any signal. So you might find out that at certain value, there is no value. Okay, so it should be like this. Supposedly, your data, the sensor can detect range like this, but at a certain distance, it doesn't detect any voltage. So this is where we call it as the sensor has a deadband. Okay. Okay, lastly, is on the resolution. So the resolution is the smallest increment in the measured value that can be detected. So resolution is actually about the similar with the gain just now, the sensitivity. But when we talk about resolution is the smallest that it can detect value. So for example, if you have a temperature sensor, 100 degree detected. So if you have a very good resolution sensor, okay, a good sensor with high resolution, then it can go up to 0.01 degree. Sometimes it can go up to milli degree. Okay, so of course, when you have highest resolution sensor, means that it will be much more expensive. Okay, so this one is a group exercise in a breakout session. Okay, so what you're going to do is that students are going to refer to the datasheet. Okay, datasheet in the ULearn just now. Yeah, each group need to this one no need refer to the group numbering. Okay, we are not going to go do that. So you are going to go do the group in the breakout session. Okay, you are going to need to submit it to the Padlet tonight at 12. Okay, so basically I'm going to give you roughly about 30 minutes, maybe too long, 15 minutes. Okay, we are 10:15 until 10:30 lah. Okay, discuss it in a breakout session. So one group, I will try to make it, we have roughly today 46 student. So 46 student, let's say if 5 student in a group, 5 student in a group. So basically 9 student lah. So 5 student in a group. Okay, so what you need to do is that you need to actually it's up to you. Okay, you want to type it in words, okay, you want to write it on a piece of paper, is also okay. Okay, as long as it's it uploaded to Padlet. In a Padlet, write your group number according to the breakout session. Group member, as mentioned, those is not responding in a group, don't put their name, and upload it as a PDF file. Okay, take a photo. Okay, I hope that by now students know how to use scanner apps. Anyone who does not know how to use scanner apps before I go to breakout? Anyone who do not know how to use scanner apps? Guys? Tahu scanner apps? Because I don't want student to submit in JPEG but in PDF. So make sure that it should be in PDF, not in JPEG. Okay, kejap. I nak tunjukkan you something. Let me just log in. Where's the link? Okay, I want to show you something. Before we go to breakout session. Bukan share ni. Cam scammer je. Boleh. Asalkan any scammer lah. Okay, sorry. Any scammer can use. Share content. Okay. Maybe my voice. Okay, can you see the screen? Okay.
Yeah.
Look at the screen. This is my phone. Sekejap. Okay, I want you to download these apps. 4-stroke auto engine, and then 3D engineering, mechanical engineering, and mechanical quiz. Just screenshot that if you have the time. But I want to give you, this one is really interesting and it was very useful later on. Annotate later on in the chapter 6, mechanical engineering. Okay. So okay, there should be a sound here, but it's not out. But anyway, if you look at here, later on, we are going to look at the engine. Okay, in mechanism, we are going to look at the type of, this is type of example of cam and flower later on. Okay, so this one is really useful. And you can just go through what is the operation. They actually explain the operation, the stroke. Okay, so try to download that later. Yes, okay. Another apps that I want you to download is this.
V6 and V6 engine refers to V structure of engine with 6 piston cylinders. In intake stroke,
Can you
piston
hear
lowers
that
in the
it's actually
cylinder,
explaining?
sucking air
And you
injector
can
pipe
actually
phase
Yes, madam.
brings fuel
look
into
at
the
the
cylinder.
X-ray value.
In compression stroke,
you can
the valves
actually,
close and crankshaft lifts the piston up, compressing fuel and mixture.
you can actually zoom it, look at it.
Igniting the
Okay.
fuel and mixture. The combustion forces the piston to the bottom of the cylinder
This
again.
is one. And they have lots of application inside here, which is very useful later on in chapter 3. So example is steering.
Power steering helps the driver of a vehicle to steer
this
by
one,
directing some of its power to assist in swiveling the steered
blah
road.
blah blah lah. Okay, so that one is very useful. So these three, Shopee pula. Yes. Okay, these four mechanical engineering point is interesting. You have notes over there, so you can download that. Alright, that will be all my sharing. Okay, so we are going to go to breakout session. I think until 10:30 lah. Okay, you are 5 groups. Okay, group number 1. Okay, in the Ulearn. Okay, I just leave that. In the Ulearn later on, you see that there are 6 data sheet. And if D7 means that group 7 also do the data cell. Group 8 do the Honeywell and so on lah. So I'm going to set the breakout session. Breakout session assignment. Number of breakout session will be 4. Then student assign participant outing. Number 9. I give you until 10:30. Alright? This for student go to breakout session. The one that you can join. Is automatic assigned. So click on join. Hishan, Nur Hazira, Kaim, Kishan? Kishan? Qayyim, are you there? Or sleeping? Please go to the breakout session. Hi, Qayyim and Kishan?
Hello. Prof.
Ya?
Saya terkeluar tadi.
Oh, okay, tak apa. Dah semua dah keluar. Okay,
Oh ya.
alright. I forgot. I'm not sure. I checked the Padlet. There's no group or update yet. Okay, but it's okay because the deadline was until midnight kan. Okay. Forgot to mention. Okay. Actually after the slide, if you did go through, okay, hopefully student bijak lah sikit kan. Don't just refer to my slide, the one that I've showed to you. In the slide, I actually share to you example how to do that. Okay, in the table, write it out like this, and then definition, figure, example from the datasheet lah. Okay, so and then I have given some example how to actually list it out and so on. Okay, so this is one of example. Okay, next we are going to go to the this one static dah. Okay, dynamic tu I think you baca sendiri je, tak nothing much. Okay, now I'm going to go to the selection of sensor. Okay, selection of sensor. Okay.
Betul nak tanya jap.
Ya.
Untuk yang exercise 2, 3 pun still group yang sama ke macam mana?
Yes, group yang sama. Group sama.
Oh.
So
okay.
sebab tu tadi saya ada shoot dalam record session kan. Make sure dah ambil siap-siap lah nama group. Dah ada ambil nama group. Siapa tu? Alah, paling senang patutnya you guys screenshot je nama tadi kan dalam record session tu. So senang. Tak sempat nak ambil. Nampak nama boleh Chris letak kan. Okay, so the same group lah.
Okay.
For today is the same group. Okay, so next, because the topic is on sensor kan. So basically what you're going to learn is you have a system later on, and then what type of sensor is suitable. Okay, so you want to actually select the sensor based on the size, okay, range and span to be measured, the type. For example, if the mechanism is a rotary actuator or is a linear actuator, so what type of sensor is suitable? Or do you need any mechanical mechanism inside there to actually convert from the translation between rotary and linear? So this is where in chapter 6, you'll learn more on if you have a sensor that can only detect linear motion, so how do you actually measure a rotary type system? Okay, so you can actually add on some mechanism in between so that you can actually measure those output. Next is the resolution. So higher resolution, as mentioned, will eliminate most of the error, because that error is that actually resolution means that you can detect very small displacement. Accuracy. So the accuracy is the difference between measure and true value. So accuracy is the plus minus just now, kan? Plus minus 2 degree. Okay. You want to have the accuracy is much smaller. Plus minus 0.1 degree is much more better than plus minus 2 degree, because you want to have a exact value if possible. What are the material of measured object? Example, if the aim of the application is to detect obstacle. Okay. For example, the obstacle. Imagine that you are near a sliding door. Okay, sliding door, and then there's an obstacle. And there's something behind the sliding door. Okay, but the sliding door is made of glass. So what type of sensor is suitable to detect that obstacle? Okay, because if you were to take a type of IR sensor, infrared sensor, it cannot detect the sliding door, the material, the glass. Okay, so it's not suitable, even though it can detect displacement, distance, or obstacle. So it's not suitable. Okay, so maybe you want to select ultrasonic sensor, because it detect based on the frequency. So when it actually detect, they will send out a signal waveform in terms of frequency, and when it actually reverse back and it detect the distance, so that is where it can detect the displacement or motion or object. And lastly, which is normally we are constrained by the budget. Okay, and especially when you're doing final year project, so constraint, of course, you want to have a very good resolution sensor. Okay, so high accuracy, but the costing is really important. So you might have limited budget, so you need to make do with whatever that we have, with the best selection of the characteristic of sensor. Okay, so those are example. And most of the time, some of the sensor, they have their own amplifier with the sensor when you purchase. So example, it has the amplifier inside here. Okay, this is the type of amplifier that we have in the lab, in my lab, research lab. So we have this is a force sensor, and we have also, this is phone sensor, torque sensor, and it's connected to the amplifier box. Okay. So let's look at example of a rotary electromagnetic actuator here, mechanism setup. Okay, so which one do you think is the actuator and which one is the sensor? Is it A or is it B? Which one?
Actuator.
A or B?
A.
A actuator, sensor?
Sensor is B.
Sensor is B. Okay, so that's correct. Very good. So if I were to, let me just find the video. Where's the video? Electrical actuator. Okay, this video. Mana video dia? Ya. Nampak tak actuator? Okay, this is the actuator showing the top view. Okay, the actuator, because this is made from electromagnetic actuator, so you see this coil there. This one is displacement. At the same time, we have the encoder at the back there. Okay, so those example of the actuator, maybe that one not too clear. Another example. Okay, this one is a linear actuator. So you see that the whole thing is an actuator. The sensor is over here. Nampak tak yang ni, yang warna hijau ni yang menyala? This one is the sensor. It's actually, if I play that again, it's detecting the displacement. Okay, so this mechanism at the hand here, we call it as a table. It's connected to the shaft, electromagnetic shaft here inside here, so it will detect the motion. So basically this one was built by my master student. Okay, a master student. Previously he was my final year project student, and he did his master and he graduated with master 2 years ago. Okay, so this one is example. So in this setup, you see that actually a similar setup. We have the amplifier over there. Okay, the input to the system, the actuator, and we have a DSP board. And we have the power supply, which is this amplifier. And we are using the rotary encoder to detect the rotation. So in this another example, I cannot find the video, but later if I find it, I share to you. This will actually detect the rotation of the actuator. This is a rotary actuator in compared to that one just now was a linear type actuator. Both are designed by my student lah. Okay. And okay, just go to very fast. So let's say that you're going to measure the rotation. Okay, rotation of the actuator. Because in the end you want to control the displacement. You want to control it if displacement 0.1 degree, 0.2 degree displacement. So you might be thinking, where do you actually use this type of small displacement? Okay, remember just now the process that I showed to you in the semiconductor system, manufacturing system, the die bond processors, the wire bond processors. It require very small displacement in nanometer or in millimeter, very small. So this is where you need to have this type of control. Control very small in micrometer displacement, or we call it as precision. Okay, motion. So my field is on precision motion, designing controller and designing actuator, very small scale one. So for this type of application, so you want to have the size of the range. Of course, for a rotation, you need to have a 360 degree. The type that you need are rotary type actuator. Of course, if you don't have a rotary, because rotary sensor might be very expensive, so you want to purchase only a linear type. So you can also use a linear type sensor, but you need to convert from the rotary to linear type. Okay, means that there will be a mechanism in between the actuator and sensor. The resolution, I want the resolution to have at least 0.1 degree resolution. Accuracy 98%, means that plus minus 2%. Material is ferromagnet, means that the measured object is ferromagnet. And the cost within budget. For example, I have a grant, okay, research grant. So it's within my budget, so I can purchase it. So this one is another task, which is a deadline is by Friday. Okay, and this is you need to submit to Yulen. Okay, the one that I showed to Yulen just now. So in a group, okay, by referring slide 59 to 88. So basically, okay, what you need to do is that refer to that slide. Student also may refer to textbook or other reference online available at the library. Okay, following the measurement sensor, fill in the template. So displacement, position sensor, okay, proximity sensor, velocity motion sensor, force sensor until light sensor. Okay, based on all of these, for example, for displacement sensor, list 2 example for each input devices and explain its working principle by using a diagram. Okay, so in a group, you need to delegate tasks. I hope that when you have a group member need to have a team leader. Ketua siapa? That team leader needs to delegate tasks accordingly. Okay, so everybody need to do the task. Okay, tak boleh ada silent, panggil silent partner lah. Silent partner ni kita tendang keluar je. Kalau dia tak nak kerja, tendang keluar, tak payah nama dalam. Okay, so saya memang kejam sebab kita nak as a team work together. So give example of output devices actuators. So based on this displacement, so give also an example of actuator that can be used with this displacement sensor that you suggest. Okay, so for example, for the measured quantity is position. Okay, yang ni lah position, measured quantity position. Okay, so what are the input sensor picture? So I choose 2 because in here you 2 example. So 2 category of sensor under this position measured the quantity. So I choose incremental encoder, and another one is potentiometer. So output devices, where can it be connected? To a motor. So potentiometer, where can it be connected? Okay. Theory of the principle and diagram of the principle. Okay, so this is where you need to search from references. So you need to do for each of the measured quantity. This is measured quantity. For example, velocity sensor. Find 2 different types of category of sensor. Okay. So, a lot lah ni. Kalau macam ni, 9, 9/2, 18. So, 18 divide lah by 5 students. So, mana? Dapatlah berapa kan? So, divide the task accordingly. And another exercise 3 is also the same thing, group. Okay. So, basically, based on the group just now, okay, breakout session 1 to breakout session 9 tadi, okay, refer to the list of Mechatronics project in Wakelet. So, I have shared in Wakelet. Okay, Wakelet is, we have all of this, ada 10, I already upload 10, okay. So this example, maybe you will get different topic from the chapter 1 just now because of the switching of the breakout session. Okay, so based on that, what you need to do is, this is example. Okay, example of, one of the example in final project was on the design and delivery of mobile robot for inter-office document. So the objective was to avoid obstacle avoidance. Okay, so maybe from the obstacle avoidance, you are thinking, oh, okay, there are 2 different types of sensor can be used. You can use a position sensor or proximity sensor. For line following, you might want to use light sensor, or you can use other types of sensor. You can suggest at least 2 different types of sensor based, I think, is it 2? Yeah, 2 types of sensor. So at least 2. Okay. So based on that, okay, this is one example. Just go through. This one is one example of one case study. So what you need to do is that, based on each of your projects, okay, case study lah. So if you get a case study on the rehabilitation for exoskeleton, so select the best sensor for the task and explain the reason why the sensor was selected based on measurement system. So in the video, they might not mention what was the objective of the project. So you need to think, oh, okay, this project was doing this one and this one to actually actuate the lower limb, so that to, and so on and so on. So based on that, in the video they might explain what type of sensor is being used, okay, what type of mechanism being used. So you need to identify it on your own. If it's not in the video, then try to search it using YouTube or Google. Okay, think of it as a task that you need to solve. Okay, how many sensor do you think that is required? If you think there is more than 1 sensor required for that task, so you list it out. Okay, but based on the video, case study video, if it say that maybe you think there is 2 side sensor because it need to detect the position. So one is at the top position and one is at the lower position. So you need to have 2 sensor. So based on that, the third one is that assign the base location to mount the sensor and explain your reason. Okay, draw the front view, side view, top view. No need to draw using CAD lah, sketch je. Okay, so this one submit to Padlet. Okay, upload it, and I would suggest for this exercise number 3, exercise number 2, you can use Word if you want. Okay, and exercise number 3, submit it in PowerPoint slide. Means that for the first one, maybe one slide, second slide, third slide. So at least 3 slides for this task, and upload to PDF, and convert it to PDF and upload to to Padlet. Okay, so the deadline for exercise 2 and 3 will be on Friday, and the deadline for exercise 1 will be today by midnight. Okay, any question? I think that will be all. So basically, for exercise number 2 is that, okay, it looks a lot, but basically everything from slides 59 and 88 covering all of it. So you just need to go through the slide. Okay, you see here the slide 58, 59 is on displacement sensor. So it's explained about this displacement sensor, position sensor, and so on. So maybe the information here is not complete. So this is where you need to do some benchmarking, refer to some other reference. Okay, so all of these are already inside the slide, and you need to do some extra probing on your own. Okay, any question? Any question? Okay, if no question, then after you completed everything, so basically I have uploaded in Ulearn the deadline lah. Deadline for all. So in week 2, you can see that the deadline for exercise 1, okay, only one person submit, team leader. So you need to select whoever. Maybe for exercise 2, exercise 1 is a different person as a team leader. Exercise 2, a different person as a team leader. So everybody get to switch between team leader in that same group. So team leader need to submit the Padlet. Okay, exercise 1 deadline is tonight, and exercise 2 and 3 is by Friday. Exercise 2 is to Ulearn. Here is the Ulearn assignment. So submit that. One person only. So I will actually check that total just now we have 9 group kan. So 9 groups. So basically I will see that there is only 9 person submitted. And don't forget to put your group member name inside. Okay, so after finishing by Friday, then only you fill in the feedback form. Okay, feedback form here. Okay, feedback form will actually ask you regarding okay, this one I don't want. I already asked you about the breakout session kan. Okay, so I'm going to ask you to summarize what you have learned based on the category of sensor, and then basically what you don't understand regarding week 2 class Okay, any question? Let me look at the chat. Okay. Just now, mana tadi I think ada 2 orang yang tak masuk breakout. 2 orang tak masuk breakout session Kaim. Kishan dan Kaim. Kaim dan Krishan. Ada ke? Tadi tidur ke? Kaim? Kishan? Ini actually breakout session is where I detect student not active in class So don't do that. Okay, I think if there is nothing else, so that be all from me. Okay, can exercise be upload in Word? Convert lah PDF, jangan Word. Convert PDF. I would say convert PDF, jangan Word sebab nanti Word orang copy kerja you. Convert PDF. Okay, because you are submitting to Padlet kan. With Padlet, I will tell to all my students, if you submit to public contents, don't upload something in words that can be edited. Okay, submit in PDF or PDF lah. Okay, so follow the instruction lah. I say PDF lah, janganlah pergi submit Word. Okay. Internet problem, doctor already inform in Telegram. Okay, next time make sure no problem lah. Okay, tak apalah Kishan, but make sure that you catch up with the other student Okay, so that will be all. Thank you very much. See you. By the way, before that, next Monday I think next Tuesday is cuti awal Muharram awal Muharram lah. Maulid Rasul, hari Selasa. Okay, so Selasa off, but Monday we have class, and Monday basically I'm going to give you a quiz lah. Basically what I did yesterday, quiz on chapter 2. Okay, so please go through everything, and on Monday we have 1 hour to finish up the quiz and quiz 1, chapter 1, you can still redo it until you get almost full mark Alright, just to clarify, we have to upload all of the assessment on Padlet. No, Luqman. Okay, saya nak kena explain balik lah ni, tak faham Okay, dalam bahasa Melayu, I hope tak ada foreigner dalam ni. Okay, week 2, saya ada tulis dah dalam ni. Okay, kena tengok Ulearn. Instruction saya, kalau tak ada masa ni, mungkin tak dapat tangkap. Dalam Ulearn ada full instruction. You can ask your team member juga. Okay, ada 5 orang team member. Tanyalah kawan-kawan, hari tu doktor suruh submit kat Padlet ke Ulearn? Salah, tak tahu kat mana. Pergilah check Ulearn. Ulearn ni tempat yang paling, mau cakap paling tepat lah untuk you refer. Okay, so di Ulearn, again, I repeat, exercise 1 to Padlet, exercise 2 to Ulearn, exercise 3 to Padlet. Okay? And deadline dia dah letak sini, deadline dia berapa bulan. Okay, faham Luqman?
Betul yang exercise 3 tu buat dalam Word tukar PDF balik
Iya.
Okay.
Iya, tahu tak macam mana nak convert Word ke PDF?
Tahu.
Kalau tahu, buat. Kalau tak tahu, saya demo. Saya kalau tak tahu, saya boleh demo. Kalau tahu, saya tak demo lah. Sebab nanti orang cakap takkanlah tak tahu nak buat convert Word ke PDF kan. So, okay. Kalau tahu dan semua adalah in PDF lah. Upload ke Ulen
Puan,
dan PDF. Ya?
tadi Word ke atau PowerPoint?
PowerPoint. Save as PDF. Macam saya bagi nota kat you. Saya bagi nota you dalam bentuk PDF kan? Tapi sebenarnya saya design dalam PowerPoint. Boleh faham?
Boleh.
Yang tu exercise 3 je. Yang satu tu kau buat dalam Word tak apa.
Tak apalah,
Sebab tu tukar
mana-mana
PDF.
lah asalkan PDF. Senang cerita. Saya nak senangkan you. Kalau you buat dalam Word, berjurai-jurai nanti. Kalau dalam PDF sebab dan untuk PowerPoint tu, kalau boleh jangan PDF kan lah besar-besar macam ni. Sebab nanti saya nak suruh student present. Tahu, faham? Padlet tu, saya nak panggil student according group next class akan present dia punya output tu. Okay? So, janganlah you pergi PDF kan macam saya buat ni. Okay? PDF kan satu page, 3 slide. PDF kan satu page ni, 2 slide okey lah bagi saya. Okay? Alah, mana-mana yang senang lah. Kalau kecil pun nanti, you yang susah nanti nak present. Okay? So, faham? Okay. Kalau dah faham, saya nak tanya balik pada you all semua ni. You all semua dari entry student kan? Okay. Dah buat pendaftaran subjek ke? Untuk subjek
Dah
ni?
buat.
Belum lagi Doktor.
Puan.
Okay. Yang belum lagi tu, kenapa belum buat lagi
Kita orang tengah tunggu untuk ni transfer kredit dulu.
Okay, faham. Tapi adakah subjek ni you transfer kredit ke tak?
Transfer.
Transfer.
Okay, berapa orang yang transfer kredit subjek ni? Maknanya you dah pernah ambil lah.
Ramai kot.
Rasa semua.
Rasanya semua.
Semua transfer
Semua
kredit?
dapat entry.
Dalam DE.
Tak semestinya. Tak semestinya semua transfer kredit. Sebab you daripada different politeknik, syllabusnya lain-lain.
Tu Nik Syarul tu tak transfer.
Okay, berapa orang ni yang tak transfer? Boleh letak kat bawah tu. Yang tak transfer. Sebab sekarang ni Dr. Fahmi, tapi are you sure? Okay, kalau tak transfer tak apalah. Hopefully whatever yang saya ajar ni memang pernah belajar di diploma dulu lah kan. Sebab this is really important untuk you punya final year project. Sebab kalau you tak faham apa yang saya ajar, dan unfortunately, final year project you nanti haru biru. Okay, saya tak transfer So, I think ada lah. Maknanya ada yang tak transfer, so should be okay. Sebab Dr. Fahmi, another lecturer, in section 1, dia mention, kelas dia ramai, 60 orang because of pelajar lama. Pelajar lama means that not direct entry are transferred to him. So, dia punya pelajar ada dalam 60 ke 70. In contra to my class right now, kita ada cuma 46. Tapi I do not know siapa yang actually join kelas saya ni. Sebab you guys cakap you guys akan transfer kan. So, I do not know how many saya tak. Okay, ramai yang tak. Saya tak sebab saya diploma elektronik. Okay, thank you. So, tak semua saya remindkan balik. Tak semua pelajar direct entry akan transfer. Basically those yang in Mechatronics saja. Direct entry Mechatronics. Mungkin yang ambil dulu Mechatronics saja akan transfer. Yang lain tak transfer sebab dia tak pernah ambil subjek ni. Okay, so okay, that's all. So those yang do not actually transfer credit for this subject, make sure that you do the registration Make sure dah buatlah proses registration tu, dah submit kepada kepada unit akademik FKE melalui punya PA Okay. So that will be all Thank you very much for class today. So hope next week before Monday I will actually upload the instruction for class in Ulen So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you,
Bye,
Doctor.
thank you, Doktor.
Salam.
Thank you, Doktor.
Thank you, Doktor.
Goodbye.
Bye, thank you, Doktor.
Sama.
Thank you, Doktor.